Hey everyone, we are back. And what are we back with? Check it out. The Titanic. We just did gender, sex, male or female, and realized that you were more likely to die, drown, a horrible death if you were male. Chivalry will never die. I would have said to the female, to the women and children, it would have been offensive in this age if I let the women go because, we're all equal. So if I were there, I definitely would have taken that boat and stomped on everyone and get the hell out. But that's me. I'm Mr. Equality. I'm a feminist, right? So, women and children first, outdated concept. But that's just me. Now, let's test another thing on this. Another theory. Does classism exist? First, second, third, fourth. So we're just going to do the same thing. Now, one of the things about Rstudio I love is you just hit the arrow up. You got iceberg. So let's just call this 2, right? Iceberg 2, as factor, survive. But instead of sex, we're just going to hit passenger class. Check it out right there. That easy. Keep it binomial because you still have a dependent variable that's binomial, yes or no. That's what logistic regression is. And boom, you've got it. So we just did that easy. Summary, instead of iceberg, we already know the results of that. We're doing iceberg 2. Here we go. Well, check this out. Now, why do you think passenger class first is the base? Well, it's pretty easy to understand why this is the base because look at here, third, second, so first is the base. But notice you still see statistical significance here, and you're more likely to die. -10 is higher, and then -4 here. And look at this. This is even higher, and you've got a good standard of error, and you've only got 100, but it looks like that decrease is enough. Remember, residual, just the lower the better. So something here is happening. We've got this similar results as before. We got the Z value, standard of error low, which we need. That's the repeated samples we would have if we had to keep on doing this. We don't want repeated samples because we don't want people dying in the middle of the ocean. But the point is that this is a very good model indicating that class matters. Any Marxists out there? Well, I don't think you have to be a Marxist to know class matters because, if you're poor and rich people are going to have more opportunities. What a surprise, right? So here you go with the passenger class second, but we're only comparing this to the base to the first class. One of the interesting things when you have more of these nominal variables here, first, second, third, actually you wouldn't know, but it doesn't matter. These are the independent variables against this logistic regression. You want to know how they all pan out, not just how third against first and second against first, because that's the base. These two are compared to the base. But you want to know what about third and second compared to each other? How do we do that? There's an interesting package. You should by now know how to get packages out, but I'll just get mine out of the library. Remember, you have to install this package with the quotes, but here you don't need quotes. It's the amines package, EMMEANS. Check it out. So now we can do something here that's pretty cool. I want to know whether these variables, right, are all significant when we match them up. Third to first, second to third. Third to first, third to second, because we already know second to first is. We already know third to first is because that's what it compares. So watch this. Amines, just the regular thing. This is called a pairwise test where you're taking these variables and comparing them to each other. That is the independent variables. You have the same dependent variables, but you have different attributes of this independent variable. So what's the name of this? This is iceberg 2, right? They're called pairwise, T tilde, and what's the independent variable here is passenger class. Now this is a perfect contrast. So look at this. Let me get my little pen here. The first and second, are they significant? Yes. you're more likely to survive. Notice the Z ratio is positive because this is the first. It goes against that if you're in first class. So this is here and this is here. So that means first you're likely to survive. First, third, you're more likely to survive significantly. Look at that, 10 for the Z ratio and a really low p-value. Remember, as we talked about the p-value before, the p-value is actually questioning whether the null is true or not. How likely you are to see results if the null is true. That means there's no relationship between these variables. The lower the better. Look at this, 0.0001. So that's way below 0.05, the threshold. Then you've got second against third, right? You're more likely to survive if you are in, let's see, log odds. This is the Z ratio. The higher, the better for your model. Statistically significant. This means if you're first and second, you're more likely, a statistically significant relationship. You're more likely to survive if you're in first. First and third, way more likely to die if you're in third. And second and third, you're more likely to die. It's statistically significant, to survive, sorry, if you're in second. So each class compared to each one, the higher the class, the more likely you are to survive. This is very interesting. This is called the Tukey method, which we'll get into even more when we do the Tukey test in ANOVA. But regardless, this is what they call a pairwise test. So let me repeat really quick what's going on here. What's happening here is, like, unlike sex, these variables have three attributes: second class, third class, and first class. So if you look, you've got the first class, third class, etc. Where's that second class? The smallest, yep, second class. So these are passenger class. There's not one, like here you just have sex, male, female. So what you have here is the third class and second class to the base, first class. First class is the base because one becomes before 2 and 3. That's statistically significant. You are more likely to survive if you're in first, or die here because they're negative if you're in second and third compared to first. But I want to compare second class to third class as well. That is why we have the amines. So if you take a look at the amines, first and second, first right here, you're much more likely to survive. It's positive estimate, and the Z ratio is pretty high, and you've got a statistically significant p-value, which means it's statistically significant. Same with first and third, same with second and third. So these are just comparing those attributes of the variable passenger class. What happens if we had fourth and fifth? Then those would be here, first and fourth, second and fourth, third and fourth. So you're just comparing these right here, first and second, first and third, second and third, and they're all statistically significant, meaning class matters. You are more likely to survive if you're in a higher class, or another way to say it, you're more likely to drown and die if you're in a lower class. What a surprise. Now, that shouldn't be surprising. This is what makes statistics interesting and fun. I don't know if drowning is fun. I guess you could say that now because it happened so long ago. If it happened yesterday, we wouldn't be able to do it. But you could look at this with earthquakes. You could look at this with other types, like where do you live? You could literally, if you get the data, during horrible things like hurricanes, Katrina or something, people in neighborhoods were they more likely to die than people in other neighborhoods, etc. So you can take this statistical analysis and apply it to a broad range of different things. But remember, the dependent variable survival are not as logistic because you only have two binomial. That's why we wrote binomial in it. Two results. Fail, not fail, win, lose, etc. So you could do this politics, etc. It's kind of interesting, right? You could literally do this male, female, vote or not vote in a presidential election. Do you vote? Do you know who's more likely to vote? You could apply this to a broad spectrum of different stuff. But this is really, really interesting from a historical point of view because we're testing about a real case, the Titanic, lamentable. But at the same time, we found out two things. You are more likely to survive if you're female, and you're more likely to survive if you're in a higher class. Very interesting and fun, although it's a lamentable situation. I don't want anyone to die and drown in the middle of the Titanic, but they got what they knew where they were going. No, I'm kidding. It's kind of a sad situation. They never thought it was never going to sink. And it did. It hit an iceberg. So take care, everyone, and I hope you enjoyed this.